Alright, so for this example, it says the graph to the right shows velocity of the particle moving along the x-axis from 0 to 11. It consists of a semicircle and 2 line segments. Use the graph and your knowledge of motion to answer the following questions. So the first is find the total distance traveled by the particle over the time interval 0 is less than or equal to t is less than or equal to 11. So when we see total distance, we know total distance means the integral from a, so from 0 to b, which is 11, of the absolute value of v of t dt. So when we see this, that's the same as saying take this and just flip it and make the area under the curve positive. So I'm just taking that, reflecting it over the x-axis, and everything stays the same. We're just making it positive. So this is going to be the area of this semicircle, which is 1/2 pi r squared. So 1/2 times pi, and I have a radius there of 2. So 1/2 pi times 2 squared, plus the area for this triangle, and I see here that I have a base of 6 because from 4 to 10 is 6. So it's, 1/2, my base is 6, and my height is going to be 6. Plus the area of this triangle, which is going to be 1/2 base times height. So 1/2 times 1 times 3. So 1/2 pi times 2 squared is just going to be 2 pi. 1/2, 6 times 6 is 36. Half of that is 18. So plus 18 plus 1/2 of 1 times 3 is 3 over 2, or 1.5. And that will be the same as 19.5 plus 2 pi. Alright, so moving on to part B. So part B says find the value of from 0 to 11 of v of t dt and find the meaning of the integral in the context of this problem. So this one is actually going to be pretty similar to what we did before, except now we're just keeping the signs. So this means that what we're going to do is we said that here, we said the area under that semicircle, so from this so the area of the semicircle we said was 2 pi. And then the area under this triangle, it's below the x-axis here. There's no absolute values. It's below the x-axis. So it'll be negative 18. And the area of this triangle here is going to be plus 1.5. And so now this is going to be 2 pi minus 16.5. So what this means in the context of the problem, we said that the antiderivative of velocity is going to give us the displacement of the particle. So if it's a definite integral and we take the antiderivative, it gives us the displacement. So basically, this is telling us how far away the particle is from where it started. So from wherever it started, it is 2 pi minus 16.5 units away. But all we have to say is the displacement. So the displacement sorry, this is very slow, of the particle. So of the particle, you can say after the first 11 seconds, or you can say between t equals 0 and t equals 11. It's like between, or you can say over the interval 0 to 11. I spelled that wrong. Another E in there. So between t equals 0 and t equals 11 is negative 16.5 units. We don't know units, so I'm just going to say units. And that says is right there. So the displacement of the particle between t equals 0 and t equals 11 is negative 16.5 units. All right, moving on. So the initial position of the particle x sub 0 is 2. Find the position of the particle at time t equals 11. So this is not bad at all. This is just saying, basically for a position, it's saying take the initial position, right? So this is just like what we did last unit. So take the initial amount, and we said an integral represents the change. So we're adding in the change from our initial point, which is 0, to our final point, which is 11, of v of t dt. We know x of 0 is 2, so I'm going to say 2 plus, and this we got in our last problem, of the 2 pi minus 16.5, which is 2 pi minus 14.5. So the particle's position at t equals 11. So where the particle is 2 pi minus 14.5.